But at least I knew it was too easy. Bless us. Okay, so grab a template. What variable are we testing? Well, what's the matter? What's the matter, bro?
There's a calculator issue.
There is.
It has a dim mismatcher because it's putting zeros in one list, and I don't know how to resolve that.
Oh, that's just rounding. Dim mismatch means you've got one too few data points somewhere.
Yeah, but it looked like they matched up. It just was putting zeros down on the left column. And so
That means you have different numbers of zeros. There's one extra zero. You have to take all. There's one extra zero here. You just gotta keep hitting delete on until they go away. Just keep hitting that. Yep, just keep hitting. It doesn't look like you are. There you go. It'll work now. It'll work now. What variable are we testing? It's mu. It's an average. It's an average. It's not a percentage of those that are higher. It's the actual decibel level. We're going to measure that. It's using some kind of sound measuring device. Cool. They have these on cell phones now, which are great. I don't know how precise they are, but they're accurate-ish.
And the variable.
What variable, mu? How are we going to define mu? What's mu going to be?
Are the commercials louder than the
Well, let's put that in. I love that. But what I want to do is I want to attach that to a number. If I use that as my mu definition, I can't put a number to it to test an MIT test. So let me ask you a question. What did we just do to our data? We're going to get the bell curve in a second, but what do we actually do to our data before we get the bell curve involved? What did we do in our TIs together? We compared them by doing what? We compared the differences, didn't we? Mu is going to be the average difference between a commercial and its show. And I'm putting commercial and show. I know I wrote it a little bit differently up here. I put between show and commercial. I'm putting commercial and show because that's how you guys told me to subtract them. Commercial minus show. And the reason that's important is if you subtract them the other way, you'll get data that's negative or positive of the previous data, and that could confuse us, correct? If we had subtracted the other way, we would have got a -9, and then we'd be like, oh, looks like the commercials are actually quieter, but it says the same thing, it's just in a different way. That's why I think it was logical to do what you guys said. But I want to make sure, because it's subtraction, that we kind of keep that talked about. Fair? Good? Good. All right, good. So, and the reason, Frankie, I love what you said about, it's the comparison between are they louder than the shows. We got to numerically get this to fit on a bell curve, don't we? So here's the bell curve. We'll put that up here in the corner because we haven't gotten to our hypotheses yet. There's a reason for that. What number always goes in the middle? So, but what I always like doing too is putting a contextual number under that to what we're actually talking about. Yesterday, Tuesday, it was either 100 for IQ points or it was 30 for a speed limit. Here's a bit of a trick question. What's it going to be today? It's going to be 0. Because it has to be, right? Remember what you guys said? We want to look to see if the differences are statistically significant, but numerically they are either or positive or negative. What separates positive and negative numbers?
0.
That's the whole point. You need to compare it using 0 as a comparator. Using 0 as a comparator, you need to figure out what that's going to be. Is that believable? You guys buy that logic? Maybe you don't. So, give you a heads up. Whenever you analyze data like this, when you subtract 2 data sets, one of the quizzes I posted for next week deals with this. It deals with checking IQ scores of 6 kids before and after a reading assessment. You assume that there's no difference. So we're going to assume in the null hypothesis there is no difference between commercials and their shows. Well, if there's no difference, there's 0 difference.
Right.
We're trying to show that there isn't 0 difference. We're trying to show that there is a positive difference, which would make the commercials louder. So essentially, we know our data is over on this side because it came back positive. The question is, did it come back positive enough to put us out here in this beautiful 5% region? Or is it just a little bit to the right of 0? Not enough to trigger a, oh, we better call Congress and send them money to make a law. Fair? Stop me right there before we go any further. If you want to. We can also just keep going. Decent? I know it's Thursday, week 7. You guys are champs for showing up. Conscious. Uncaffeinated. Or caffeinated. Whatever.
Yeah.
Yes. Not enough caffeine. Good. Yes, not hard. So now, what are the hypotheses going to be? Let's at least get the hypotheses down. Down here. Mu, right? Mu, for sure. What's our claim?
Greater.
Yes! The claim is that that's true. Yes? That's a 0, by the way. Not a weird A. That's the claim, yeah? That's what Congress is trying to support. If we can prove, now I know it says greater than, but it means statistically greater than, statistically significantly greater than. If Congress can show this, then I really have to go like, okay, maybe I buy your little committee. Maybe I buy your little committee that makes commercials quieter, okay? The opposite of that is everything else, right? So, and again, the reason, Frankie, again, I love what you said about we're trying to show commercials are louder than shows. This allows us to do it symbolically. We're trying to show that the average difference between a commercial and its show is greater than 0, which means that the commercial is louder than its show on average. Yeah, that's what we're trying to show. Trying to see anyway. So you see if it support their conclusions. Is that fair? Yeah, maybe. Is it believable? Maybe that's fair. Believable. We're more interested in believability. All right. Let's talk about the errors, then kick you out of here and get some fresh air in this room. Type 1 error. Good. False positive. We say the commercials are louder when they're not. Type 2 error. Saying they're not louder when they are. Which one's worse? Oh, I like this. Dissension in the ranks. Type 2, type 1. False negative, false positive. Give me some justification for either one of those, either one of your calls. Who says type 1? Why do you think? What do you think? If you don't mind, Sheldon?
Well, because I mean, it's going to be going to Congress and all that.
Because now you've made an error and we're going to send it to Congress. Congress is going to love it because they want to appease their voting base. They're like, oh, we found data that shows commercials are louder. That means I can make a law that then gives people jobs because then the FCC has to hire more people to actually regulate that. So Congress people love it, but it's all based on a potential false call. So type 1, good vote for type 1 being wrong. I love that. Who says type 2? Give me a reason, Veronica.
Well, because you could be getting blasted and they're saying you're not.
Exactly. You could be getting blasted by the data. You know, I mean, who knows how much hearing loss is going to occur? But you know, if you're sitting there 3, 4, what's the average American watch? Whatever that means. A couple hours of TV a day. I'm driving that down myself personally. But you know, there could be some kind of a damage occurring when I mean, it could be minor or mild. He's always like, I don't buy that. That's totally fine, sister. I'm not saying you're going to be right or wrong with these. I'm saying just pick your least favorite and tell me why you think it's your least favorite. Yeah. So either type 1 because we're sending. It's just like saying a drug works and sending it to the FTC or FDA. Excuse me, FTC. When it doesn't work, that's a bit of a problem. Whereas a false negative, we let something go that should have been taken care of. So your call on that one.
Well, taxpayer money too, because obviously.
That's going to be a type 1 issue, isn't it? Because if type 1 would result in more taxpayer money spent.
Yeah.
Because type 1 would send it to Congress. Type 2 would be like, oh well, commercials aren't that loud, so we're not going to send it anywhere.
Right.
Probably. That's the thing about reporting negative test results. It doesn't happen that often. I'm not saying it shouldn't. I'm saying it doesn't happen all that often. Cool. What do you guys say? Want to take 5?
Yeah.
Let's take 5. We're halfway through the test. That's perfect. Let's take 5. Then we'll run the numbers and we'll see what the results are. Yes.
So
Yes. Thank you, Amai, for that email. I'm sorry I didn't get